Hello everyone, I'm very glad to introduce the project of Higher Intelligent Factory using the powerful capability of MEC. It was a very famous and important project that we have done together with GSMA, China Mobile, Haier, and Huawei Vision. Especially the capability of MEC will speed up and enhance the 5G to support the industry digital transformation. So let's take a look. Haier launched in last year in July this 5G plus AI interconnected factory, and is targeted to improve the efficiency from the manpower to the machine and even to the process. So take the use case of the machine vision as an example. Supported by 5G and AI machine vision, the product quality can be increased by 28%. Another interesting use case is the AR collaboration, also supported by 5G, is to help remotely diagnose the fault and help to fix it. And the result can be, the downtime can be reduced by 25%. Besides, also supported by 5G real-time data collection and supported by IoT analysis, the scene's efficiency can also be increased a lot. For example, the machine efficiency can be increased by 40%, and the distribution of the material efficiency can be increased by 30%. Last but not least, the 5G makes the production line very friendly to the environment by reducing the energy cost of more than 25%. And we see that the core of this is 5G DN. So you might ask, what is 5G DN? And what's the capability it can provide? So last month, we have launched the 5G DN white paper. 5G DN is the 5G determinist network. We summarized from more than 100 scenarios in more than 10 verticals that the requirement from the industry usually can be 3 dimensions. The first one is a dedicated network. Unlike the consumer user, the industry users usually have quite different requirements from each other. That's why the differentiated network is a necessity. The second one is a dedicated network. It's also almost the common requirement from different verticals to isolate the data and to protect the data privacy. The third one is the DIY network. We know that a lot of industry customers, they also have their end users. In order to serve them very well, they need to customize and manage part of the network resources by themselves. So based on the requirement analysis, we summarize there are 4 core elements that we should provide as a suggestion for the operators to design and to deploy the network. We call it CORE, C-O-R-E. The first one, as we say, is a cloud-native architecture. It's the basis to provide a dynamic resource allocation. With the key technology of microservice and also the container-based architecture, it can help the resources to be put in the right position. The second one is one integrated core. It's very easy to understand. Besides 5G, the existing terminal and service of 2G, 3G, and 4G should also be integrated. Even the message and voice should also be integrated. The third one is a real-time operation. That means that the network should provide a big automation for the industry to use it. For example, if a media company wants to use the network slicing to broadcast a football match, they should be able to purchase the network slicing online through one-click provision, then remotely can manage and operate the resources by themselves. The last one is edge computing. 5G DN uses MEC to provide the differentiated connectivity, and MEC have the capability to provide various combination of connectivity and computing capability. For example, they can provide the broad bandwidth plus the video rendering for the live streaming, and they can also provide the low latency plus the machine vision for the manufacturer. So overall, this is a 5G DN definition. And then in June last year, we together built the 5G DN alliances. We call it 5G DNA because we hope to build the DNA for 5G to support all the industry transformation. And the vision is through the ecosystem cooperation, we can build the 5G deterministic network to set up the end-to-end ecosystem and finally supported by all the supply industry chain to put it commercially as soon as possible. And until now, we have already developed more than 80 members, and Huawei, China Mobile, Haier, and Huawei are all in it. So let's come back to Haier project. Now we are focusing mainly on 3 scenarios. The first one is the machine vision. It has been explored for many years in the factory to replace the human inspection. However, the current solutions still have big space to improve. The wireline connection has a very big limitation of the cable length, and also they need to take very long time to plan the route and to deploy it. Also, now they put the silo machine vision IPCs for each of the inspection points. I have been to Haier's factory. They have 4 checking points for one typical production line of the refrigerator. So they need to put 4 IPCs. The second use case is AR collaboration supported by 5G and MEC in order to shorten the response time for people to diagnose the fault and fix it. However, it requires large quantities of local rendering. Therefore, they will have to bear very huge cost for the terminals. And also the broad bandwidth and the low latency are necessary conditions for it, which the current 4G and Wi-Fi has difficulty to achieve. The third one is the video surveillance. We hope it can be more advanced and intelligent. Not only see the condition by the people, but also can provide some analysis and provide some alarm if necessary, if there are some behavior not in compliance. So 5G and MEC support very well all the pain points and requirements I have mentioned, especially the capability of the MEC. So let's have a look of Huawei's MEC. It's mainly composed of 3 parts. The first part is the ubiquitous connections. The MEC brings the connectivity capability of 5G like broad bandwidth, low latency, reliability, and security to the terminal and service. And on the other hand, MEC can also provide a very dynamic policy control like the ULCL, like the LADN, to enable the network have a very harmony collaboration with the service and terminal, depend on the service own requirement for the bandwidth and the latency. The second one is heterogeneous architecture, but with ultra-high performance. In the future, there will be large quantities of applications running on this platform. And each of the applications might need quite different hardware. For example, some of them might